Hi and welcome to the session. In this session, we are going to discuss about the topic factors affecting on the rate of corrosion from Unit 6 Corrosion Science. The learning outcome from this session will be students should be able to recognize factors affecting the rate of corrosion and students should be able to give the solution to avoid the corrosion. Basically, there are two factors which affects the rate of corrosion. First is the nature of metal and second is the nature of environment. So in this session, we will discuss about factors involved in the nature of metal. First is the position of metal in the galvanic series. It has been observed that higher the position of the metal in galvanic series, higher will be the tendency of that metal to behave as anode and more will be the rate of corrosion. Then if there is a larger difference between the position of these two metals which are in contact with each other in the galvanic series, then the rate of corrosion will be high. Vice versa, if the position of the two metals which are in contact with each other have close position in the galvanic series, then the rate of corrosion will be less. Then second factor is the relative areas of anode and cathode. Larger the area of anode, lesser will be the rate of corrosion, while larger the area of cathode, higher will be the rate of corrosion. Simply, larger area of cathode will require large amount of electrons and hence the anodic metal will undergo fast corrosion. If area of anode is larger in size, then sufficient amount of electrons can be given to the cathode and the requirement of electron from the cathode will be less in that case and hence the rate of corrosion will be less. So if two metals are in contact with each other, then if the area of the anode is larger, then that anode will undergo corrosion slowly, while if the cathodic area is larger, then the anodic metal will undergo faster corrosion. So for better design, anodic metal should have larger area. The next factor is purity of the metal. Higher the purity of the metal, lower will be the rate of corrosion. So pure metal is less prone to the corrosion, while if impurity increases, the rate of corrosion will be enhanced. So impurity will enhance the rate of corrosion. If the impurity is passive, the rate of corrosion is less. That means the impurity will act as a cathode and the rate of corrosion will be less. If the impurity is active in nature, that means the impurity will act as an anode. In that case, severe rate of corrosion will be there and that will be a localized corrosion which will lead to the formation of pits. The next factor is the physical state of metal. Here physical state of metal means the grain size of the metal, then orientation of the grains and stress and unstressed part present on the metal surface. It has been observed that smaller the grain size, larger will be the rate of corrosion. For example, steel has smaller grain size than the cast iron, hence it corroded more easily than cast iron. While in case of stressed and unstressed part, areas under stress will act as anode and can be easily get corroded, while unstressed area present on the metal surface will act as a cathode and they will not affected by the process of corrosion. The next factor is the nature of oxide film. We know that there are 4 types of metal oxide films. If the oxide film formed on the metal surface is non-porous, then it will protect the metal from further corrosion. If the film is porous, then the corrosion will continue till the metal is completely corroded. And the last factor which is categorized in the nature of metal is overvoltage. Metal having higher position in the galvanic series than the hydrogen undergoes corrosion by hydrogen evolution mechanism. During the hydrogen evolution, tiny bubbles of hydrogen gas adhere on the metal surface. Subsequently, the acidic solution loses contact with the metal surface, leading to the lower corrosion rate. Hence, metal behaves as it is having lower position in the galvanic series. To restore the position of the metal in galvanic series, some extra voltage is needed to apply, and this extra voltage is called as a overvoltage. Hence, the metal do not have tendency to adsorb hydrogen corrodes at its usual rate, and the metal which is having tendency to adsorb hydrogen corrodes at lower rate. Metals like zinc, chromium, lead has overvoltage nature. So here, suppose there is a metal, and this metal there is a anodic and cathodic area, and this metal surface is covered with the acidic solution. Now in this case, the hydrogen evolution mechanism will occur and there will be formation of a hydrogen bubble on the metal surface. Now this hydrogen bubble will detach the contact of this acid medium with the cathode. So here the corrosion will be lowered due to the detaching the contact of the cathode with the corroding medium, and hence the metal will act as a metal which is having lower position in the galvanic series. So if certain extra voltage is applied to this metal, then the metal will again start behaving as a metal with its actual position in the galvanic series, and this voltage is called as a over voltage or over potential. So in summary, we have discussed about the factors which are involved in the nature of metal. In that we have discussed about position of the metal in galvanic series, relative areas of anode and cathode, purity of the metal, physical state of the metal, nature of oxide film, over voltage or over potential. Thank you for watching this session.